Advanced Math, Set 103, Calculations with Logarithms and Power of the Hydrogen. Okay, so if we were going to multiply 10,000 by 100, there are a couple of different ways to do it. The first, we could use powers. We could say 10 to the fourth times 10 to the second, and then just add the powers to get 10 to the sixth. If we used logarithms, we would write it as log of 10,000 times 100, which is log of 10,000 plus log of 100. The log of 10,000 is 4, the log of 100 is 2, so we would get 6. If we wanted to do the cube root of a million using exponents, we could write 10 to the sixth to the 1/3 power, which would equal 10 squared. Using logarithms, you just have to remember that rule that the log of x to the n power is the same as n times log of x. So if we had log 10 to the sixth to the 1/3 power, that's the same as saying 1/3 log 10 to the sixth power. And then that would be 1/3 times 6, which equals 2. Okay, so write the following expression as a single logarithm. So the first thing that you want to do when we're looking at something like this is take the number that's in front and write it as a power. So 3 natural log of x squared minus 1 becomes natural log of x squared minus 1 to the 3rd power. So then the next one would be minus natural log of y to the 2nd power minus natural log of x plus 1 to the 4th power plus natural log of y squared plus y to the 2/3 power. From here, we're going to use those subtraction signs and the addition sign. And if you remember, if you have a subtraction sign, it means divide, and if you have an addition sign, it means multiply. So we have the natural log of x squared minus 1 cubed. Then minus means divide, so y squared goes on the bottom. Minus, so x plus 1 to the 4th power, again, goes on the bottom. And then it's a plus, so we put it on the top, y squared plus y to the 2/3 power. So now we can simplify. X squared minus 1 is the same as x plus 1, x minus 1, and we just put it to the 3rd power, each of those to the 3rd power. Then we can pull out a y, so we get y times y plus 1, each of those to the 2/3 power, all over y squared times x plus 1 to the 4th power. From here, we can cancel. So we have x plus 1 on the top and x plus 1 on the bottom. We have the 3rd power on the top and the 4th power on the bottom, so that leaves us with 1 x plus 1 on the bottom. Then we look at the y's, and we have y to the 2/3 on the top and y to the 2nd on the bottom. So y to the 2/3 on the top, and if we turn y to the 2nd into a third, then it's going to be 6/3 on the bottom. 2/3 on the top, 6/3 on the bottom leaves us with 4/3 on the bottom. And then everything else is going to stay the same. So we end up with natural log of x minus 1 to the 3rd power, y plus 1 to the 2/3 power, all over x plus 1 times y to the 4/3. And that is our solution. Okay, expand the following into the sum of logarithmic expressions, each of whose argument is linear. That each of whose argument is linear basically means that you don't have any powers, so the powers need to be brought to the front of the logarithm. So we have log of xy cubed over the square root of x plus 1 times z cubed. So the first thing we need to get rid of is that square root sign. So we're going to get the log of xy cubed, and then over the quantity x plus 1 to the 1/2 power times z to the 3/2 power, because the square root is 1/2, and we're just multiplying that through. Okay, the next thing that we're going to do is simplify this out so that we write it all in without a fraction form. So we have log of x plus log of y cubed minus log of x plus 1 to the 1/2 power minus log of z to the 3/2 power. And then the last thing that we need to do is get rid of the powers. So we have log of x plus 3 log of y minus 1/2 log of x plus 1 minus 3/2 log z, and that is the solution. Okay, talking about power of the hydrogen, that's power of the hydrogen is pH. So if you've heard of pH before, that's what it means. And basically what it says is that it's basically what pH is the concentration of hydrogen ions in a liquid, and that determines the acidity or the pH of a liquid. So when we're talking about the pH of any particular liquid, we're really talking about how many hydrogen ions are in that liquid. In the equation that we're going to use, H plus represents the concentration of hydrogen ions, and pH is the overall acidity. pH goes from 0 to 14 with one of, I can't remember which one, it doesn't go into it in this lesson. One of them is acidity and one of them is basic. And 7 is right in the middle, being neutral. So the equations for pH, the exponential form is 10 to the negative pH equals H plus, or the logarithmic form is pH equals negative log of H plus. So we'll do a couple of examples. Find the pH of a liquid if H plus is 4.03 times 10 to the negative 6 mole per liter. So these are relatively simple. If we're given H plus, we're going to use the pH formula. So we get pH equals negative log of H plus, and then we just plug in H plus. So we get pH equals negative log of 4.03 times 10 to the negative 6. And then you just plug that in your calculator. Negative log 4.03, and then you use the button that says EE that looks like this. And that button is going to give you the times 10 to the negative 6. So what you would do is you would write in your calculator, you would put in the log button, and then you'd put 4.03, and then you do the EE button, and then negative 6. And then that's going to give you your answer, which is 5.39 rounded. Okay, next problem. Find the concentration of hydrogen ions in the pH of if the pH of the liquid is 7.05. So this one we're going to use the first equation, the exponential form. So 10 to the negative 7.05 equals H plus. And then all we need to do is plug that into your calculator, 10 to the negative 7.05, and that gives us 8.91 times 10 to the negative 8.